Let's go to the program itself. In the program, we defined the program as RGB bargraph. I've written send connect RGB. That needs to be done before using the RGB array. And then send connect analog into in 1. That's because the potentiometer is attached to input 1. Then k is 1. And while k is not equal to escape, proceed the program. That's a statement that's written to keep the programming in a loop while esc is not hit the escape button. K is get key reads the buttons on the machine. So if you hit the escape button, K shall be escape and the while loop shall be stopped. Then send read analog in reads the sensor value of the potentiometer. It's a value between 0 and 10,683, I believe. It's 2 to the power of 14 minus 1. Get potentiometer is the reading into a variable. And then n is potentiometer divided by 4 to range the sensor value of the potentiometer in the area between 0 and 4096. Then the program continues still in the while loop for I 0 to 7. So for all the 8 LEDs, LED 0 to LED 7. And the second row, LED 8 to LED 15. That shall you see later. Green is the value of the sensor minus the value of the LED times 511. That are the graphs that we discussed earlier in the first video. If green is less than 255, then red needs to be 255. That's because red needs to be on when green is under 255. In the other case, else, red is 255 minus the green value minus 255. That's to get the triangles in the graphs. And if, so the first statement is then done, the value of green is calculated and the value of red is calculated. If the value of red that is calculated is below 0, then red needs to be 0 because a value in the negative isn't possible with the RGB LED. You can't set a value in the negative way. And then also that is ended the if statement. The programming continues with if green is greater than 255, then green is 255, because you can program a value that is greater than 255 in the RGB array. And if green is less than 0, then green is 0. That's the same reason why red can be negative. So then you have a value that is valuable for green and red. When do we then? We display at the first line the value of the sensor. We display at the second line the LED value, the string I, so which LED is turned on or off at that moment. We display the value of red and we display the value of green. That's for debugging purposes. It's not necessary if you use that in a live program to read sensor value, but it's nice to know these values. Then we continued with the latest and the most important part of the program after the calculations. We send to the RGB array the eval value from I, so the LED we want to alter, the eval value of the red and the eval value of green. So for every LED we calculate red and green and then we set it on the LED that we want to turn on. And the latest value is 0 because it's an RGB LED, so the blue needs to be off. And now the part of the second row, the eval value I plus 8, we do the same. So the LED 0 and LED 8, LED 1 and 9, LED 2 and 10 shall be the same value. So we have a double row of LEDs that are on. And because the for loop for altering the LEDs is completed, and while because our loop of the escape button is completed, and program because our program is completed.
Here you see the outcome of the bar graph program. At this moment the reading of the sensor value is 0 and all the LEDs are red 255 and green 0. If I turn on the potentiometer knob, you see that the first LED is beginning to turn yellow. The value is now of the sensor 198. That means that the LED green is also that value and red is on that LED. All the other LEDs are red 255 and green 0. When I turn the knob further, you see that the first LED is turning into green and then the second LED is turning yellow and green, and the third LED yellow and green, etc, etc. So I'm still turning the knob to increase the sensor value. When the sensor value is at the maximum, all LEDs turn green. So you have different states. You have a LED that is green, a LED that is red, but also light green, yellow, and all the states in between. It's difficult to see that on the camera. In live action you can see it much better. You see that there is a little bit lag between turning the knob and the reaction of the RGB array. That's because all the values of red and green are being calculated, and it's in a loop that the LEDs are turning on. So it's a for loop. So you see each LED is turned on separately and each value of red and green is